We've been hearing a great deal about the inner planets, but what about those remote members of the Sun's family, Uranus, Neptune, and Pluto? They are not spectacular, but I sometimes feel they are rather neglected because they are fascinating worlds. And this is a good time for talking about them because they are all on view now, and they are all pretty near opposition. In fact, Pluto came to opposition on March the 29th. And by opposition, I mean that Pluto, the Earth and the Sun were then in more or less a straight line with the Earth in the middle, so that Pluto was opposite to the Sun in the sky and well placed for observation. Then Uranus followed to opposition on April the 21st, and Neptune will do so on June the 1st. So they're all there for our inspection, and in talking about them, I think we'll begin with Uranus, which is the nearest and the brightest, and was the first to be discovered. So let me show you where to find it. We'll begin, as we so often do, with Ursa Major, the Great Bear. Well, follow through the line of the bear's tail until you come to Arcturus, the brilliant orange-red star, and then on to Spica in Virgo, and Virgo itself looks rather like a faint and distorted Y. And Uranus is here. Now, you can see it with the naked eye if you know where to look for it. I find it a bit difficult. People with better eyes can see it quite easily. Through binoculars, it looks like a star. But through a telescope, it shows a distinct greenish disk, and this is how it was first identified. It was discovered way back in 1781 by a Hanoverian musician who had come to England and taken up astronomy. His name was William Herschel, and he made telescopes, mainly 6-inch reflectors. And if you want to see a Herschel reflector, well, go and look at this one in the Science Museum in South Kensington. In 1781, Herschel was scanning the sky with one of those telescopes when he found an object which quite clearly wasn't a star, because it did show a disk and it moved. And in fact, he thought that it must be a comet, and he wrote a paper to that effect. But when its path was worked out, it was discovered that this was no comet. This was a new planet, moving well beyond the path of Saturn, which up to then had been the outermost known member of the Sun's family. And of course, this was the most exciting discovery. And after some discussion, it was named Uranus. Well, I'm afraid you're not going to see very much on Uranus with any telescope. I can show you a picture of it, and here is one taken with a major telescope. Uranus itself is very overexposed, and of course that ring and those spikes are purely photographic effects. And you can see there some of Uranus's satellites as well. But not even a giant telescope is going to show you very much on the disk. Now, this is not because Uranus is small. It's anything but that. It's a giant world, nearly 30,000 miles in diameter. And as you can see from this picture, it's a great deal larger than the Earth. But it's also a very long way away from us. Even at the moment, more than 1,600 million miles. And so it's not surprising that Uranus is not bright. It is, incidentally, a gas giant, and rather like a smaller edition of Jupiter or Saturn. But one very strange thing is the tilt of Uranus's axis. As I think most people know, the Earth's axis is tilted to the perpendicular at 23.5 degrees, and that's why we have our seasons. And most of the other planets have tilts of the same nature. But Uranus is different, as I can show you from this diagram. Here, first of all, we have the Earth's axis, you can see, and the other planets are much the same. Mercury almost upright, Venus upside down, actually. Mars, about the same as the Earth, over to the right of your picture now. Then Jupiter, pretty well upright. Saturn, roughly the same as the Earth. And then we come to Uranus, where the tilt is more than a right angle. And beyond that, Neptune, where again we're back to normal, and about Pluto we know nothing. But this strange axial tilt of Uranus means that sometimes we see the equator presented to us, and sometimes we see the pole. And it leads also to a very odd calendar, because Uranus takes 84 years to go round the Sun, but less than 11 hours to spin on its axis. And if you work that out, you can find that there are over 65,000 Uranian days in every Uranian year. And this alone will make the calendar a bit complicated, but the axial tilt makes it worse. And each pole has a midnight sun lasting for 21 of our years, and then a corresponding period of darkness. So the calendar is very odd indeed. But I can assure you it doesn't upset the Uranians because there aren't any. Uranus is not a world where any Earth-type life can exist, and because it is made up of gas in its outer layers anyway, we simply can't land there and never will be able to do so. But I suppose, in the dim and distant future, we might be able to land on one of Uranus's 5 moons. all of which, shown in this picture, are considerably smaller than our moon, but nevertheless they are solid worlds, and possibly one day they may be approached. So there is Uranus, as I say, quite easily visible with binoculars, although the satellites are pretty faint, and you're not going to see very much on it. Now, when Uranus had been found, and as I say, this was 1781, the solar system was again assumed to be complete. But when a planet is discovered, the mathematicians set to work and calculate its orbit or path. And before long, it was found that Uranus just was not behaving. It was wandering away from the position where it should go. So something was very wrong somewhere. And the suggestion was made that there might be a more remote planet, as yet undiscovered, pulling Uranus out of position. Now, this suggestion was made in the 1830s, and a report was actually sent in to Greenwich Observatory. And at Greenwich Observatory, the Astronomer Royal was a rather formidable gentleman named Airy, afterwards Sir George Airy, a great administrator. But Airy didn't take the suggestion very seriously, and nothing was done. Then, in the early 1840s, the problem was taken up by a young undergraduate at Cambridge, whose name was John Couch Adams. Now, Adams had in fact got the key to the whole problem, because he knew how Uranus was being tugged, and he had to find the culprit. So he worked out where he thought the new planet must be, and again he sent the results into Greenwich. And once again, nothing was done. Then, over in France, the same problem was attacked quite independently by a French mathematician named Leverrier, who was a very brilliant man indeed, and also supposed, I think, to have been one of the very rudest men who had ever lived. And Leverrier made the same kind of calculation and came to the same result. And he sent his calculations in to the observatory at Berlin, who started hunting for the planet. Meanwhile, over in England, Airy had at last instigated a search, and so the race was on. And the Continentals won it, because at Berlin, the planet was identified on the basis of Leverrier's calculations. So, in fact, Adams finished his work first, but it was by Leverrier's work that the new planet, Neptune, was actually discovered. And I may say this led to quite an international row afterwards, in which neither of the principals took much part. In fact, I'd like to show you too just what the situation was. And here we've got a diagram of the paths of Uranus and Neptune as they were round about that time. Uranus the inner, Neptune the outer. Before 1822, Neptune was pulling Uranus along. And then after 1822, as now on the diagram, Neptune was pulling Uranus back. And it was by that kind of calculation that Neptune was eventually tracked down. Well, in addition to that, Neptune has got two satellites, and they're both rather interesting. They're very different in type. The smaller one is called Nereid, and that goes round Neptune in a rather peculiar kind of path, more like that of a comet than a planet, as you can see there. It's very strange indeed, and it's so small you can't see it except with a very powerful telescope. Now, the inner satellite is called Triton, very much bigger than our moon, I may say, and was discovered not long after Neptune itself. And that goes round Neptune in practically a circular orbit, but the wrong way. And just why that happens is something else we don't know. Now, let me show you where to find Neptune. We can go back to the same chart we used earlier, because at the moment, Neptune and Uranus are not all that far apart. There again we have the Great Bear, Virgo, and Uranus, and here is Neptune, on the borders of the Scorpion and the Serpent Bearer, and not very far away from the bright red star Antares. And if you've got the right kind of charts, you can identify Neptune with binoculars, and a fairly powerful telescope will show you that it's not a star, but as I've said, I'm afraid no telescope is going to show you very much on it. It's slightly larger than Uranus, slightly denser, slightly more massive, and a great deal further away from the sun, and so obviously it is colder. Neptune was tracked down in 1846, and once again the solar system appeared to be complete. But still, there was something just a bit unexplained about the movements of Uranus and Neptune itself. And this problem was tackled by a very famous American astronomer whose name was Lowell, Percival Lowell. And there he is, and he, in fact, is best remembered today for his theories about the canals of Mars, which turned out to be wrong. But he was also a very brilliant mathematician, and he made the same kind of calculation as Adams and Leverrier had done so long before, only this time, of course, it was more difficult. And he worked out a position for a still yet undiscovered planet. And since he had a powerful observatory, he started looking for it. The observatory was at Flagstaff in Arizona, and there's the dome, photograph I took when I was over there some time ago, and inside that dome is a very powerful refracting telescope, which Lowell used for his observations, and which I know well. I've used it quite often, so I know how good it is. And yet, although Lowell searched energetically, the planet just refused to come to light. And by the time he died in 1916, it still hadn't. And for a long time after that, nothing more was done. But then, in 1930, long after Lowell's death, a young astronomer named Clyde Tombaugh had another look, photographically, and he took the photographs on which the new planet, Pluto, was identified. And here are the actual discovery photographs, Pluto indicated there by the arrows, and you can see how much it shifted over the period between the times when those photographs were taken. Now, when you're talking about a great astronomical discovery, it's very nice to be able to speak to the man who actually did it. Clyde Tombaugh, whom I know well, was over in England not so long ago, and while he was here, I asked him how certain he was about Pluto.
Well, I was not too familiar with it. I was aware of it, of course, but in view of the earlier previous searches, I was not sure that it was in that neighborhood. And when I embarked upon it, I thought I would go all the way around the sky, searching it very systematically, and to see whatever would come out, and whether it was a predicted planet or even some others. And so that was the basis for making the search.
Was it fainter than you expected?
Yes, it was, as far as Lowell's prediction was concerned. He had a magnitude of 12 and expected a planet comparable to Neptune. Not quite as large. I think he had a mass sign of 7 Earth masses. And of course now we know Pluto's much smaller than that.
Everything seemed fine, but was it? Pluto turned out to be very much smaller than expected, even smaller than the Earth. And a planet of that size just could not drag either Uranus or Neptune out of position by a measurable amount. And yet it was by those very perturbations that Pluto had been tracked down. So there's something very strange about the entire thing. Either Pluto is larger or more massive than seems likely, or else the discovery was sheer luck, or else there's another planet out there somewhere. I simply don't know. And Pluto has a very strange path. It's much more eccentric than those of the other planets, and it actually crosses Neptune's, as you can see here. So it can come closer in than Neptune ever does. But because Pluto's orbit is tilted, there's no fear of a collision on the line. And don't forget, too, that Pluto takes 248 years to go once round the Sun. I can show you where Pluto is. We can go back to our original diagram, showing Uranus and Neptune, and here is Pluto, again not far from Virgo. But you're going to need a powerful telescope to identify it. If you would like to see a 1975 chart of its movements, here is one sent in to us by Mr. Walter Pennell of Lincoln, and that shows the movements of Pluto during the present year. And Mr. Pennell also sent us 2 photographs of Pluto taken some time ago, and there's the planet on the end of the arrow, and once again you can see the motion. But, as I say, you're going to need a pretty good chart and a pretty good telescope to identify Pluto. And whether it really is the outermost planet, well, that remains to be seen. We've got, I think, to wait for the era of space probes. But I think you'll agree that, unspectacular though they may be, these remote members of the Sun's family are certainly not without their interest. I must, I think, end this Sky at Night on a personal note. We did our first program in April 1957, and we showed then the spiked comet, Arend-Roland, and I wonder how many people remember that now. Since then, we've been on the air once every 4 weeks, and we haven't actually missed a month since April 1957. And so this month we come of age. We've been going now for 18 years. And I would like to thank very sincerely all those of you who have been watching our Sky at Night programs for this time. And I only hope we get the chance to carry on for another 18 years. And so, with this anniversary program, I'll say goodbye now and see you next month.